Video 13. Grid connected systems with battery backup. Grid connected systems with battery backup is also known as battery based utility tied systems or battery based grid connected systems. These systems ensure a continuous supply of electricity despite blackouts. A grid connected system with battery backup consists of a PV array, an inverter, safety disconnects, main service panel, meters, batteries, and charge controller. Although grid connected systems with battery backup are similar to batteryless grid connected systems, they differ in several notable ways. One of the most important points is the type of inverter. Battery based grid connected systems require a special type of inverter, one that can operate in sync with the grid but also off grid from batteries. Another more obvious difference is that battery based grid connected systems require a battery bank. The third difference is a meter that allows the operator to monitor the flow of electricity into and out of the battery bank. The fourth difference is the charge controller. It regulates the battery charging the PV array. Batteries. Batteries for grid connected systems with battery backup are either flooded lead acid batteries or more commonly low maintenance sealed lead acid batteries. The first point worth noting is that battery bank in grid connected systems are typically small. That's because they are usually sized to provide sufficient storage to run a few critical loads for a day or two until the utility company restores electrical service. Critical loads might include a few lights, a refrigerator, water pumps, oil-fired boiler. They are a backup source of power and they are not there to supply additional power. Grid power. When demand exceeds supply, the grid makes up the difference, not the batteries. When the sun is down, the grid, not the battery bank, becomes a home or business power source. Amp and amperes. Electricity is the flow of electrons through a wire. Like water flowing through a hose, electricity flows through wires at varying rates. The rate of flow of current depends on the voltage. The flow of electrons through a conductor is measured in amperes or amps for short. An ampere is a certain number of electrons passing by a point per second. The greater the amperage, the higher the number of electrons flowing through the circuit. To gain a better understanding of power produced or power consumed, we have to consider the flow of electricity over a period of time. An amp hour is a quantity of electrons flowing through a wire equal to 1 amp for a period of 1 hour. This term is also frequently used to define battery storage capacity. A flooded lead acid battery, for example, might store 420 amp hours of electricity. Because this is a pretty unfamiliar term, I recommend that amp hours be converted to kilowatt hours, a much more familiar term. To calculate kilowatt hours from amp hours, simply multiply voltage of the battery with amp hours. A 6 volt 420 amp hour battery, for example, stores 2520 watt hours or 2.5 kilowatt hours. Batteries fully charged. It is also important to point out that the battery bank in grid connected systems are maintained at full charge day in and day out. to ensure a ready flow of electricity if the grid goes down. Keeping batteries fully charged is a high priority of these systems. Maintaining a fully charged battery bank requires a fair amount of electricity over the long haul. This reduces system efficiency. Batteries require a continual input because they self-discharge. That is, they lose electricity when sitting idly. You've seen it happen to flashlight batteries or car batteries that sit idle for months. Because of this, batteries require a continual electrical charge and therefore become a regular load on a renewable energy system. Meters in a battery-based system also typically display battery voltage. For experienced renewable energy operators, battery voltage provides a general approximation of the amount of energy in a battery. If, for instance, a battery is not being charged or discharged, the higher the voltage, the more energy it holds. The lower the voltage, the less energy it stores. Because charging a battery bank raises voltage and discharging lowers the voltage, you only get an accurate state of charge voltage. Charge controllers. Another component found in grid-connected systems with battery backup is the charge controller. The charge controller regulates the flow of electricity into a battery bank. Modern charge controllers and inverters often contain a function called maximum power point tracking. Maximum power point tracking circuitry optimizes the output of a PV array, thus ensuring the highest possible output at all times. Pros and cons of a grid connected systems with battery backup. Grid connected systems with battery backup protect homeowners and businesses from power outages and enable them to continue to run critical loads during outages. Although battery backup seems like a desirable feature, it does have some drawbacks which are summarized below. One of the biggest downside is higher cost. They are about 30% more expensive than batteryless grid connected systems. The higher cost, of course, is due to added components, especially the charge controller and the batteries. Batteries require maintenance and a warm vented storage room or battery box, resulting in additional costs. Pros. This provides a reliable source of electricity and provides emergency power during an utility outage. Cons. More costly than batteryless grid connected systems and less efficient than batteryless grid connected systems. This is less environment friendly than batteryless systems, require more maintenance than batteryless grid connected systems. Because grid connected systems with battery backup are expensive and few people install them, when contemplating a battery based grid connected system, you need to answer three questions. How frequently does the grid power fail in your area? What critical loads are present and how important is it to keep them running? How do you react when the grid fails? If the local grid is extremely reliable and if you don't have medical support equipment to run and your computers aren't needed for business or financial transactions, you have a wood stove for heat and you don't mind using the candles on the rare occasion when the grid goes down, then why buy, maintain and replace costly batteries? So here ends video 13, grid connected systems with battery backup.